Next problem, if x of t is a Poisson process, then prove that probability of x of s is equal to r given that conditional probability x of t is equal to n, which is equal to ncr s by t power r 1 minus s by t power n minus r, where s is less than t. We know the distribution function of Poisson process. Probability of x of t is equal to n e power minus lambda t power n by n factorial. That is equation number 1. Now probability of x of s equal to r, conditional probability, given that x of t equal to n means probability of conditional probability law. Probability of x is equal to r into, that is intersection, and x of t equal to n divided by probability of x of t equal to n. We know probability of a given b, probability of a intersection b by probability of a or probability of b, right? A given b, probability of b, b given a, probability of a, like that, right? Probability of a intersection b divided by probability of a or probability of a intersection b given by divided by probability of b, either probability of a given b or b given a, right? B given a or a given conditional probability. Same like that, instead of a we are having x of s is equal to r and b x of t equal to n. So a intersection b by probability of b, right? So probability of x of s is equal to r intersection probability of x of t equal to n intersection probability x of t equal to n divided by x of t equal to n divided by, right? Probability of x is equal to r intersection, so we remove, because t is greater than s, so we are removing those parts. When we are taking intersection, same will be removed, right? Suppose if you are taking intersection of 1 to a set 1, 2, 3 and another set 1, 2, 4, then what is the intersection 1, 2? Like that we are removing the remaining parts. We will get probability of x is equal to r intersection x of t minus s, which is equal to n minus r, right? Probability of x of t equal to n, since s is less than t. Then probability of x is equal to r intersection probability of x of t minus s is equal to n minus r. Both are independent because this is s, this is the remaining part t minus s, right? So this is r, that is n minus r, remaining part. So divided by probability of x of t equal to n. So we are using probability distribution function, Poisson distribution function, e power minus lambda s, t is equal to s, n is equal to r, lambda s power r by r factorial. Second one, t is equal to t minus s, n is equal to n minus r, e power minus lambda t minus s, lambda t minus s power n minus r by n minus r factorial. Similarly, in the denominator, t and n is n, so e power minus lambda t power n factorial. So grouping this, so taking the denominator in the reverse ways, right? So we will get n factorial there, right, divided by e power minus lambda t power n. Then numerator, in the numerator we are having denominator numbers r factorial, n minus r factorial, they will come down. So n factorial, n minus r factorial. Then the remaining terms, e power minus lambda s power r and e power minus lambda t minus s power n minus r. We are splitting all those things. First e power minus lambda s, then lambda power s and s power r, then lambda power n minus r, t minus s power n minus r. So we are grouping all those things. So we will get e power minus lambda s, e power minus lambda t, then we are splitting e power minus lambda t minus ss, e power minus lambda t, then minus into minus plus e power lambda s. So we are splitting this, we will get, so n factorial by r factorial, n minus r factorial, lambda s power r, right, lambda s power r, here lambda, grouping all lambdas, lambda power n minus 1, only one term, n minus r, right, divided by lambda t power n. So t raised to n minus r, correct. Down we are having t power n, right. So we are taking t outside from the t minus s brackets, right. So if you are taking outside, so you will get t power n minus r, right. So balance 1 minus s by t power n minus r. So we know n factorial by r factorial into n minus r, that is nothing but ncr. So lambda s power r, and then lambda power n minus r as it is, down lambda power n into t power n, we are splitting, then t power n minus r, so 1 minus s by t power n minus r. So ncr, splitting lambda power r, splitting the power s power r, lambda power n minus r, lambda power n, denominator t power n, t power n minus r, 1 minus s by t n minus r, which is equal to ncr s power r, grouping lambda, correct, numerator lambda power n minus r, down we are having lambda power n, we are taking the lambda power r in the numerator to the denominator, so it will become n minus r, right, lambda power n minus r, then t power minus n, because we are having t power n in denominator, so we are taking to the numerator t power minus n, then remaining you are have t power n minus r, 1 minus s by t power n minus r. So grouping all those things, ncr s power r, t power, grouping all the t's, so powers, so what are the powers, minus n plus n minus r, right, for t. So we will get 1 minus s by t power n minus r. So ncr s power r, t power minus n plus n cancel, t power minus r, 1 minus s by t power n minus r. So we are grouping s and t, because s power r, t power minus r, so we are taking t power minus r to the denominator, we will get 1 by t power r, so s divided by t whole power r, right, that is ncr s power r, t power r, 1 minus s by t whole power n minus r. So ncr s by t power r, 1 minus s by t whole power n minus r, which is the one. Thanks.